Hey everybody, what's up and welcome back to another video. In today's video, we're actually going to be experimenting a little bit with wallet abstraction. And what we're going to be going over in this video is an experiment that one of our engineers built. So what we're actually going to be experimenting is an on-chain way to authenticate a user sign-in. So a quick overview of what's going to be covered in this video. We'll first take a look at a quick demo of this experiment and application. We'll then take a higher look and kind of go over the reasons why we created this and a high level concept of how it works. We'll then get going and deploy some of the contracts that we need to build this out, and then we'll actually build out this application that we demoed. So without wasting any time, let's jump on the computer. Let's go over the demo first before we get into how exactly it works. So on my computer here, you can see I have an on-chain login. It says login with a username and password. So ideally what this is going to allow us to do is we can hit login. All we need to do is provide a username and a password. And what this is going to do is check if this username already exists within our smart wallet factory. And we're using this password to essentially gain access to that account. So if I hit login here, it's checking if the username exists. It does exist, so it's accessing the wallet and now connecting the wallet directly for us. And what this is going to do is now bring us to our account. So my username is right here, followed by my smart wallet address. Down here is just a demo showcasing an NFT collection that we can claim. The claim is free, gasless is turned on, and here are the collectibles that I own. So if I claim a collectible, what this is going to do is claim a NFT from this ERC-4337 NFT drop. Again, we are using our smart wallets from thirdweb, and this allows us to enable gasless transactions with a paymaster. And this allows us to enable things like gasless transactions. So you can see here, I just claimed another NFT. And again, don't need to sign anything, don't need to pay any gas. All of this is happening behind the scenes on the blockchain. But it's really great because, again, a user just needs to sign in with a username and password. So I'm just going to refresh the page here. We're going to sign in with a new username. So I'm just going to say demo. We'll just create a password. So this is what happens if a username does not exist. What we're going to do is log in here. So it's checking to see if the username exists. It's a new username. So it's registering this username on chain to our account factory, and it's registering a new smart wallet to this username. So this does take a little bit because there is a little bit more going on behind the scenes when registering a new account, which we're going to cover in a little bit more depth right after we finish this demo. So you can see here, it logged us in. It says welcome demo, which is our username. We have our wallet address for our new smart wallet account. And then we have our NFT collection here, and we have no collectibles because this is a brand new account that hasn't collected anything yet. Again, we can claim a collectible gasless. You don't have to sign any transactions. It's going to claim this all from this smart contract, and then we'll be able to view our collectibles right here on the right. And there you go. We just collected an NFT. We now have one of those NFTs. So again, that's how we can log in to a username if it exists or doesn't. If we put in a username and we put in the wrong password, it's going to check the username. It's going to try and access the on-chain data, but it's not going to be able to access it without the correct password. So it's going to give us an error and we'll have to try again. And then again, once we put in the right password and log in, we'll be able to access that data and connect directly to that wallet. So now that we kind of got to see the demo, let's now go over what does this solve, how does it work, and kind of understand the concept of the application before we start building it out. So when we talk a little bit about these wallets, how can we build a better experience if we were to use a combination of wallets? We have things like ERC-4337 smart wallets, which are smart contract wallets. The only thing with smart contract wallets is you still need an EOA wallet to connect and get access to that smart wallet. So you're still interacting with an EOA wallet. We have a wallet called local wallet, which is a wallet that is generated on the local device that the user is using. The only problem right now with local wallets is it's backed up locally on that device. So if you were to create a local wallet on a computer and then you were to go to your phone or another computer, you would still have the issue of not being able to access that wallet unless you exported it, transferred it over, and then re-imported it into the new device. And we also have MPC wallets, but then you introduce a middleman, right? It has great user experience. There's a recovery flow and everything to it, but then you're now relying on a third party to store that one part of your recovery shard. So again, you're introducing another middleman or company to that equation. But with this wallet abstraction experiment, what we're looking to do is, can we take the best of all of this and create a wallet experience that covers everything? So again, in that demo that we just went over, this is a fully on-chain and non-custodial way of accessing a wallet. And this is using the combination of a local wallet and the programmability of a smart wallet. You're going to be able to do things like cross-device. So you could log in with the same username on your computer, go onto a mobile device, log in with the same username and password, and access the same smart wallet. It'll be gasless because with smart wallets, you can enable gasless transactions. And on top of that, because we are using ERC-4337 wallets, you can now have the ability to program, recover, and make it interoperable with each other. So you can build upon this and add your own functionality like recovering passwords. And you can also program it to limit what it can be used for and everything like that you would normally get from a 4337. So again, in our demo, we were able to log in with a username and password. It checks that username for us and then connects us to our smart wallet account. So how does it work, right? We're going to cover a high overview of how it works before we get started and actually building it out. So if we look how it works here, this is kind of a flow chart to how we take the username and password and then get it to connect to our application. So again, when a user signs in, they're only providing a username and password. We have a custom account factory here that actually ties the username to a account wallet address from that account factory. So what it does is when a user enters their username and password, we're checking that username if it has an attached wallet address already within our factory, if that wallet address has been deployed already. If it hasn't been deployed, right, we'll go no account. What this is going to do is generate a new local wallet. Now, that local wallet, again, is a wallet that is going to be generated on the local device, and it's encrypted with a password. What we're going to do is take the password that the user provided and encrypt that local wallet with that password. We're then going to upload that encrypted wallet. So again, normally if you wanted to use your local wallet on another device, you would have to export the encrypted JSON file, transfer it over to the device you want to use it on, and then import that encrypted JSON file and decrypt it with your password in order to use it on another device. Essentially, what we're going to be doing here is exporting that encrypted JSON file and uploading it to IPFS. And at the same time, we're then going to deploy an account contract from our factory. And then we have a custom function on our factory here that is going to register the name, so the username, to the IPFS metadata of the encrypted JSON wallet. And together we register that username to that encrypted wallet. And essentially what we're going to be doing is connecting to a smart wallet using that local wallet that we generated. So what does this look like when the user already has an account? So again, user signs in with their username and password. We double check our factory to see if that username has an account contract attached. If they do, we're then going to retrieve the IPFS metadata of that account contract. We're going to download the local wallet and decrypt it with the password that the user provided. If that password is correct, we'll then be able to import the local wallet and use that local wallet to connect to our smart wallet. If the password is wrong, we won't be able to decrypt the wallet. Therefore, we'll get an error and that person won't be able to access that account or smart wallet. So again, this is an experiment using two different wallet types. We're using our local wallet along with our smart wallet. And instead of using an EOA like a MetaMask, we're using the simplicity and the better user experience of a local wallet to then connect to our smart wallet. So again, this is the concept and the workflow of how this login works, but let's actually build this out. So before we start building this out, we do need to deploy a couple contracts. Now I'm going to be using a demo NFT drop as our NFT collection that we'll be able to collect here. If you want to use one of your own, you can deploy your own NFT drop through thirdweb. We'll link down in the description a video you can follow to deploy that, but I'm not going to go over how to deploy an NFT drop in this video. Just know that we're using a sample collection right here when we build out this demo. The next thing we're going to need is our custom account factory. Now we'll link this down in the description as well, but you can come to this published contract here and you can deploy now right over here, which is going to allow you to select the chain that you want to deploy to. We'll do that in just a bit. But essentially what this custom account factory allows us to do is it has a register function right over here. And that register function takes the username along with the encrypted wallet JSON metadata URI once it's uploaded to IPFS. And we're registering that to an account contract here. So once we register, we are checking on registered and assigning the registered username to an account. So that is what this custom account factory is doing. It's simply registering that username to an account contract from our account factory. So what we're going to do here is hit deploy. We're going to select the chain we're going to deploy on. I'm just going to use the Mumbai testnet here, and we're going to select deploy now. I'm then going to confirm this transaction and then sign here to add it to our dashboard. And once deployed, I'm just going to copy the contract address here, as we'll need that for when we build out our application, right? And once we have that demo NFT collection and our credential account factory, we're now going to build out our application here. So I'm going to open up my command line and we're going to build out our application. So I'm going to run npx thirdweb at latest, and then we're going to do create app. We're going to make sure we're on the latest version here. We're then going to name our project. I'm just going to name it Wallet Experiment. We're going to be using EVM because I deployed it to Mumbai. And we're going to use Next and TypeScript here for our application. And once that is done, we'll just change into our Wallet Experiment here and open this up in our code editor. And once you have your code editor open, we're going to set up our application here. So what I'm going to do in our pages here is I'm going to head over to the underscore app.tsx file, and I'm going to set the active chain here. Let me just close this. Set our active chain here to the chain that you deployed your contracts to. So in my case, I used Mumbai, but you'll change this to whatever chain that you have selected. Next, we have our client ID. So this is going to be our client ID from our API key. And if you don't know how to get an API key, you can follow the video down in the description below. But let me just come here really quick. If you head on over to the settings tab of your thirdweb dashboard, you can then create an API key and then copy your client ID right over there. And once you have that API key, you can come on over here to your environment variables, which is this .env.example here, and you can paste in your client ID right over here. And once you paste that in there, save it, and you now have your client ID set up, and your thirdweb application is now set on top of the active chain that you have selected. Next, we're going to head over to the index.tsx file here, and I'm actually going to run this here in my, just going to open up my terminal here in my code editor, and I'm going to run this right here. We're going to run this on a localhost 3001, and you can see here what runs is the boilerplate code for our thirdweb application. Now, if we take a look at our other app here, we're going to refresh this and log out. We're going to build our login screen here, which is going to allow us to hit login and log in with our username and password. So back in our code editor, I'm just going to drop this down here. I'm going to delete everything in this index.tsx here within the return, and we're going to build out our login page here. Now, in our login page, if we take a quick look, we just have this button that toggles our login modal. So we're going to just create, again, those components really quick. So up here, I'm going to first create a state variable here for the modal. So we're just going to import useState here. So we're just going to make state variable here, just seeing if the modal is open or not. And then under return here, we're first going to create this container here. So we have our div here. We're using the styles of container. And what we're going to do is see if the modal is open or not. If the modal isn't open, we're going to display this little card here. And when it is open, we're going to, of course, display our login modal there. So again, we're displaying that first card, which is just going to have the title of on-chain login, and it's going to say login with only a username and password. And it's going to have a button here that says login. And on click, it's just going to toggle the modal, so our state variable here, if to open up the modal. And if the modal is open, we're going to create a login component. So we're going to save that. And in our file directory here, I'm going to create a new folder. I'm going to call it components. And in that components folder, I'm going to create a new file called login.tsx. So in here, we're first going to start off by getting our login props, which we're going to just take in the boolean of if the modal is open or not. And we're going to set an on close here. We're then going to create our component here. And in here, we're first going to set all of our state variables for our login modal. So we're going to copy this here really quick. And then I have all these states here. So we're going to be using useState. And just to go over it, this is for our username, for our password. We're going to have to set a signer for when we connect our smart wallet to our application. We're going to have to set our signer. We're also going to check our loading state here. So we're just going to have a state for is loading. And then we have status. So basically when we sign in, we're going to be showing the status of what is happening behind the scenes. So we're just going to have a state variable for that so we can display that status. And then we're going to have one for errors if we run into any errors like incorrect password or any other types of error. And then I'm going to add this here to handle opening and closing our modal. So if you click outside or you click the X button on our modal, we're just triggering on close here, which is going to close out our modal. And then right down here, depending on the state that we are in, we're going to display our login information here. So returning, if we do have our username and our signer, meaning a wallet is connected and everything, we're going to display a connected component here. If it is a loading state, we're going to show our loading component here. If there's an error, we'll show our error component. And then down here at the very bottom, if none of this is happening, we're going to show our login modal right there. So coming back to our index here, I'm going to give us our login modal here. And then for our login, we are going to need the is open, which we're going to set to is modal open. And we're going to set this on close and set it to false. So coming back to our application here, we look at our first one here. We have right here our on-chain login. We have our login with username and password, and we have our login button, which right now is just going to toggle back to our login modal because we haven't created it just yet. Now I do have some styling that I am going to add into here really quick. You can get the same styling in the link of the GitHub repo down below. Now if we come back to our application, you can see we still have the same login modal right here. So we have the first initial login button. We just need to now create that modal, which has our username and password inputs and our login button. So coming back into our login.tsx, we're going to create the components for our loading error and our login modal here. So for loading here, we're going to display this div here. We're going to install a couple of things. We first need to import our styles from styles home module.css. And then I'm going to create a folder here called assets. In that, I'm going to create a new folder called Lottie files. And in here, I have a couple that we are going to be using. Then we're going to also import loading, what I call that, loading Lottie from, and then we have assets slash lottie/loading.json. And we're just going to really quickly install this React Lottie loader. Right, so we will just drop this down and import this here. So again, this is just our loading card here. So while we are checking to see if this account exists or we're creating the account, we're just going to show a little card here with a loading Lottie animation. And then down here, we're going to display the loading status. So we're going to be displaying the status of if it is checking or generating our wallet. For error here, we're just going to display an error and a try again button, which is going to set error to blank again, and then we can try logging in once again. So again, it's just a try again button, and then it's just displaying that we had an error logging. And then for our actual modal, we're going to create a div here that toggles between our styling, whether it is open or not. And if you do click outside of the modal, it closes it. So that's what this on click here is for. And we had our handling outside click here that if you just click outside of the modal, it's just going to close it. We're then going to create a login card. Again, we have some styling here that depending on if it's open or not, the styling will change. So we're going to just have a little close button here that toggles the on close. And we just have a title and we're just calling it uni login here. Then we're going to create our little input field here. So we have our input. The first one is going to be of type text. It's going to be a username placeholder, and the value is going to be our username. And on change, we're just setting the username to whatever's in the input. The second input we have is for password. So type password, placeholder is password. Value will be set to the password state variable we have. And on change, we are going to set the password to the value of the input here. Next, we're going to have the button down below that is going to say login, and that button is going to have a on-click function to connect the wallet. Now, we haven't created this function just yet, but that is what we're going to do right now. So I'm just going to create this function up here. We'll make it right under here. So we're going to create a function called connect wallet. It's going to be an async function, and this function is going to do all of the things that we talked about earlier on using the username to check if there is a account contract that has been deployed already, and then getting the local wallet or generating the local wallet with the password, and then connecting that smart wallet to our application. Now, in order to do this, we're going to create a new file, and what we're going to do there is create the function and everything to do all of that wallet generation and checking if it has been registered already. First, in our file directory here, I'm going to create a new file. I'm going to make a lib file here, and I'm going to create a new file called constants.ts. So in our constants here, we're just going to store our API key, which we'll store it under thirdweb API key. And we're getting that from our environment variable that we just created earlier. We're also going to get our chain. So depending on the chain that you deployed on, in our case, Mumbai, and we're going to import that chain from thirdweb devs chains here. And then we're going to get our factory address. So I'm going to get that factory address that we deployed earlier on, paste that in there. And then we have our NFT collection here, which is going to be the NFT collection that we do claims and everything on once we have set up our login just to test out everything. So again, these are just going to be the constants that we're going to be using throughout the application once we are connected. In our lib folder, we're going to create a new file, and we're going to call this one wallets.ts. And this is where we're going to create everything to generate our smart wallet and our local wallets to log the user in. Let me just close these that we don't need anymore. So now that we have this wallets.ts file, remember let's come back and look at our chart here. Again, this is the flow that we're going to be creating. We're going to be taking the username and password, checking if there is a matching account contract that has been deployed by our factory. If not, we are generating a new local wallet, encrypting it with the password, uploading that encrypted JSON to IPFS, and deploying a account contract and registering that username and the metadata from the IPFS to that account, and then connecting the smart wallet. They already have an account. We are retrieving that IPFS metadata, decrypting the wallet with the password, importing the wallet, and then using that to connect to the smart wallet. So in this wallet, .ts file here, the first thing we're going to do is create a function to create a new smart wallet. So we're going to right here export function, and this is going to be called create smart wallet. And what we're going to be doing is generating a smart wallet, which is a 4337 wallet. And here, what we're going to do is we'll create and store a new smart wallet here under smart wallet. And again, we're going to create a new smart wallet. And when creating a new smart wallet, we have to specify here the chain that it is being deployed to. So we're going to do chain, which is going to be chain from our constants variable. We need the factory address, which is going to be our factory address from our constants variable as well. We can set the gas list here, and gas list we're going to set to true. That way we cover all the gas for the user because they're not going to have any funds or anything when we generate these wallets for them. So we can turn on gas list and we can take care of transactions like that. And then we're going to set our client ID here, which is going to be set to the thirdweb API key, or we'll set it to an empty string here. And then outside of that, we're going to return that smart wallet. So we'll import smart wallet here. So we'll import smart wallet. We don't have wallets in. So let's open up. So we'll also have to yarn add thirdweb -dev/wallets. So add that to our project here. Cool. Once that's added here, we'll be able to import smart wallet there from wallets. So again, we created a function that is going to create a smart wallet for us. We're then going to create the next function, which is going to be getting the wallet address for the user. So we're going to create a async function here. And this is going to be called get wallet address for user. And we're going to need to provide it the SDK, which is going to be a thirdweb SDK here. And then we're also going to need to provide the username, because that is the username is what we're going to be using to check if this username is registered and attached to an account contract address. So we're getting back a promise. There's going to be a string here. And for this function here, we are going to get our factory contract. So factory here, we'll just get this await, and then we use the SDK dot, we're going to get the contract. So we're going to use get contract, and we're getting our factory contract using our factory address. We're then going to get the contract address for the smart wallet. So we're going to go smart wallet address here is we're going to await our factory contract, and then we're going to call a function from our factory contract called account of username. And what we need to provide is the argument of the username that we're checking the account wallet address for. And here we are getting back a string here. And once we get that, we are going to return the smart wallet address. So again, what this function is going to be doing is getting the wallet address of the account from our account factory. So if we take a look at our credential account factory contract and we head to the Explorer here and we go under read, we're calling this account of username. And you can see here, we can just put like a username here, and you can see there is no address associated to this name yet. But if we already had an account, we would see the wallet address that was already registered to that username. And then finally here, we're going to create the function to either generate and upload the local wallet to IPFS, or we're going to download the metadata and import it and then connect it to our wallet. So here we're going to export an async function. This function is going to be called connect to smart wallet. And this connect to smart wallet, we're going to provide it our username, which will be a string. We'll provide it our password, which will be a string as well. And then we're going to also get a status callback here. That way we can have a callback of what is going on here. So we're going to make that status a string. And then of course we return a promise, which is going to be a smart wallet. So we're going to get back our smart wallet, depending if we need to generate a new local wallet to create our smart wallet, or if we're just connecting to an existing account already. So to first start off, we're going to check the username first. So we're going to set the status callback here to, we'll set it to checking if user has a wallet. And what we're going to do is get an instance of our SDK first. So we're going to create our SDK here. And we are going to do a new thirdweb SDK. That SDK is going to take our chain that we are getting from our constants file. Just scroll down a little bit. And then we are setting our client ID to the thirdweb API key that we also have stored in our constants file as well. So once we have our SDK set, we're also going to get the smart wallet address. So we're going to store this under smart wallet address. And what we're going to do here is await. We're going to await get wallet address for user, which is the function we created up here, provided our SDK and username. So we provide our SDK and username. So what it's going to do is check our username, see if it is associated with a account, and then return us that wallet address if it is. We're then going to check if it has been deployed. So we're going to check we'll just call it is deployed here. And what we're going to do here is await is contract deployed, which we're going to check this with our smart wallet address. And we also need to provide it our provider, so we can use SDK.provider. And we're just checking to see if this smart wallet address has been, which is an account contract. We're just making sure that it has been deployed already. And then depending if it has been deployed or not we're going to, again, determine which flow we have to go through. So each flow, we're going to need a smart wallet and a local wallet. So we're going to create our smart wallet here, which is going to create a new smart wallet, which is the smart wallet that we have up here. And then we're going to create one called our personal wallet here, which is going to be the local wallet that we use to connect to the smart wallet. And this is just going to create a new local wallet. And then again, we're going to check if the contract has been deployed. And if it is deployed, what we're going to do here is we're going to set the status callback to here, connecting to here. And then we're going to change this to username exist. And then we're going to say connecting. Then we're going to say accessing on-chain data. So if it does exist, again, this means that we have already uploaded the metadata to the wallet to IPFS. So we're going to have to get that metadata back. So what we're going to do here is get our contract first, which we're going to await the SDK. We're going to get contract, and we're going to get the contract of the smart wallet address. And then we are going to then get the metadata of it. So we're going to get the metadata. And we're going to get this by awaiting. And on the contract, we are going to, on the metadata, get the metadata. So this is going to get the metadata for us. But again, in the metadata, we have the username and then we have the encrypted wallet. So we need to make sure that we get the encrypted wallet. So we're going to get the encrypted wallet here. And that's going to equal our metadata.encrypted wallet. And then we'll just check to make sure that we actually get the encrypted wallet. So if there is no encrypted wallet, then we'll just throw an error saying no encrypted wallet was found. Once we get the encrypted wallet, we'll set the status callback to decrypting wallet here. And then what we're going to do is decrypt it using our password. So right here, we'll just await, and then we'll just put a new promise here for resolve. And then we'll set the timeout to 300. And what we'll do next is import our encrypted wallet and then again, decrypt it using our password. So we're going to get the personal wallet, which is the local wallet, and we are going to import it. And we are going to set the encrypted JSON to our encrypted wallet. because again, that encrypted wallet is the encrypted JSON we uploaded to IPFS earlier. And then the password to decrypt that wallet is the password that the user provided. Once we have decrypted the wallet, we then need to use that local wallet as our EOA to our smart wallet to connect our smart wallet to our application. So we're going to set another status callback here. We'll say, call this one connecting. And then we are going to await our smart wallet. And then we are going to connect our smart wallet here using the personal wallet. So that should be, again, our local wallet that we just imported and decrypted. And then at the very end, we are going to return our smart wallet. So again, this is if a user has already deployed a account contract and we already have all of that information upload. Again, we are bringing down that encrypted JSON wallet, decrypting it, using that as the EOA to connect our smart wallet to our account. Now, if they don't have an account registered already to their username, we need to create that account. So down here, we're going to create the flow for creating that new account when we don't find a deployed account contract. So again, in here, we're going to set the status callback, and we'll set it to new username. And then we're going to set it that it's generating a new one, and that we're generating a personal wallet. So what we're going to have to do is generate a new local wallet for them. So we're going to await personal wallet.generate. So we're going to generate a brand new personal wallet. We're then going to get and store the encrypted wallet. So we're going to say encrypted wallet here is going to equal, and then we're going to await personal wallet dot, we're going to export it. And again, we're going to set the strategy here to encrypted JSON. And we're going to set the password to encrypt it to the password that the user provides to us. And then similar like to how we connected our smart wallet here, we can await our smart wallet.connect. And we can connect this smart wallet using the personal wallet that we just generated right over here. But because we generated it and it's already on our device, we can connect with it immediately right over here. Now, the one thing with a brand new smart wallet is that we can get the wallet address and everything of a brand new smart wallet, but a smart wallet isn't deployed until it has a first transaction. So if you create a new wallet and you don't do anything with it, it technically hasn't been deployed yet. So what we're going to have to do is manually deploy our smart wallet. Then we can then register that smart wallet with the username and the uploaded encrypted JSON wallet to that account. So we're going to change the status callback here. We're going to change it to say uploading and registering username on chain. So what we're going to do is manually deploy that smart wallet. So we can do that by getting our smart wallet and then we can deploy it here. So we need to get the contract address of the wallet that we just deployed. So we can store this under contract here, and we're going to await. We can await, and then we're going to get our smart wallet dot get account contract. We're then going to upload our encrypted JSON wallet to IPFS. So we're going to store this under encrypted wallet URI, and that's we're going to await our SDK. And then we're going to, on our storage here, upload this to IPFS. So we're uploading our name here, which is going to be our username. And then we're going to have our encrypted wallet. Then once we have that uploaded, we can then register that username and encrypted wallet URI to the account contract. So we're going to await contract, and then we're going to call that register function, and then we're going to provide it with the username and the encrypted wallet URI. And after that, we are going to, of course, return our smart wallet. So again, that function of connecting our wallet connecting to our smart wallet is going to take the username, see if there's an account associated with it. If there is, we're using that password to decrypt the already encrypted JSON file, use that as our EOA wallet to connect to our smart wallet. If a username isn't associated to account, we're using that password to generate a new encrypted local wallet, uploading it to IPFS. And that way, if we ever need to use it later on, we can bring that down and decrypt it with that same password. And then again, connect to our application with that smart wallet. So back in our login here, login.tsx file here, we're going to come back to that connect wallet function that we haven't completed yet. And in here, we're going to check, make sure that they provide a username and password first. So if they don't, we'll just return out of the function here. But if they do, we'll run a try catch. In the error here, we're going to just set the loading to false, and we'll console log any errors if there are any. And then in the try here, we're going to set is loading to true. And then we're going to store under a wallet here, connecting to a new smart wallet. We're going to provide it the username and password that the user inputs into those input fields. And then we're going to make sure that the loading status is set to the status of the callbacks that we have set. Once we have gotten our wallet, we're going to set the signer to the signer of the wallet. So we can get the signer by just getting wallet.getSigner. And then we're going to set the signer to that. And then we're going to, at the very end, set is loading to false. That way with signer, once we get our smart wallet connected, we can use that smart wallet to interact with our contracts. And once all of that is done, so if we come scrolling down here, we're going to create this if connected component in just a bit. So right now, if someone is connected, we should just see, we'll just put some text here saying connected, but our login should work with our username and password. So if I come back to my application here, you can see we have our on-chain login. If I hit login, it opens up our username and password modal here. I can just put in a username. I can create any type of password that I want here, and I can select the login. So right now it is checking the username. There is a new username. It's generating it. It's uploading that information, so that local wallet to IPFS, encrypting it with the password that I put in. Now this takes a little bit, just because again, it is creating that wallet and uploading all of that information, as well as calling that register function from our factory contract and registering that username and attaching it to the wallet that gets deployed. Once it's done, you can see here, we have now connected to our application. Again, it is connected via a smart wallet. We'll create this little section here in just a bit, but if I refresh the page and go back again, I can log in with that same username, same password here, and we can log in, and it's checking the username. Username exists already because, again, we just created that and we registered it. So what it's going to do is get that encrypted wallet down, decrypt it with the password, use that password as the EOA wallet to then connect the smart wallet to our application. So everything is working here. Next, all we need to do is we can create a really quick connected component to test out our application. So back in our code editor here, we're just going to, in our components folder, create a new file. We'll call this connected.tsx. And this is the component we'll show once a user is connected to our application with their smart wallet. In here, we're going to create we'll just call this component connected. We have to provide it, we're going to provide it our username, and we are going to also provide it the signer. Username will be a string, signer is going to be a signer, which we will import from ethers here. Now for our component here, we're going to have to set, we're going to return our component, but we're going to wrap it with our thirdweb SDK provider. So we're going to create a thirdweb SDK provider here. And within that provider will be our connected components that we create. So we'll say connected inner here, and then we are going to pass it our username, which is going to be our username, and we'll create that in just a moment. signer here though, we are going to import from ethers. And for our thirdweb SDK provider here, we need to provide it with our signer, which is going to be our signer. We have to give it our active chain, which is going to be our chain that we get from our constants file. And then we're going to also get our client ID, which is going to be our thirdweb API key that we get from our constants file as well. So let's just import that. Go wrap these in brackets here. And this is going to create us a new instance of our SDK here that we can now provide with some components here that are going to be our application. So down here in our connected inner, we're just using the username. We're grabbing the wallet address of the account contract. We're just truncating it really quick so we can make it a bit smaller and use it in our application. And then I just built an application using the NFT collection. So we're getting our contract, getting the contract metadata so we can display some information about the contract. And we're also going to be displaying the owned NFTs from the contract. And again, we can use this using the use contract hook to get our NFT collection contract. We can get the metadata of that contract by using the use contract metadata. And we can just use the used owned NFTs, give it our contract that we got up here, along with the address, and it'll check and return us the owned NFTs of that address on top of the contract. And in here is just a application of a container that displays the NFTs. It has an NFT claim here, which displays the NFT image along with a Web3 button, allowing you to easily claim one NFT from the collection. And then in our owned NFTs component here, if you own no NFTs, it's just going to display you don't own any collectibles yet. And if you do, it's just going to map through the owned NFTs that you have. And for each one, it'll render out an image and a card for it with the name of the NFT. And then we went back into our login here. And again, in that first section here with the username and signer, we're going to put in our connected component there. And if we come back to our application, you can see we have our username, our account contract here. We have our collection, which we can claim. We don't own any collectibles here, but what we can do is claim a collectible. Again, for our smart wallet, we have gas list turned on, so gas list transactions are taken care of. This is just claiming the NFT again in the background. Once it's claimed, we should see it in our collectibles right over here. And there you go. You can see we have our NFT here with the NFT name, which is just NFT in this case. We can, again, refresh, log in. I can log back in with that same information, checks the username, checks if it is an existing user, accesses that on-chain data, decrypts the wallet, connects me using that local wallet that we just got, with using that as the EOA to our smart wallet and connecting us to our application. So again, that was our wallet abstraction experiment video, really showcasing how you can use thirdweb's wallet SDK in combination with different types of wallets and really create a unique user experience. Remove the things like weird user experiences when having to deal with wallets. This is fully on-chain as well, and all of the information stored from username and everything is stored on-chain. We didn't need to build any type of backend or anything to manage all of our accounts and usernames. Everything is done using our smart wallet and local wallet setup. Now again, this was an experiment and there are still things that could be improved on this concept. For one, the password is not recoverable in the example that we just went through, but you could create and program your smart contract in a way where you could be able to retrieve a password if forgotten. In this case, if the user forgets their password, they lose out on ever getting their wallet back, because we need that password to decrypt the local wallet in order to import it and use it to connect to our smart wallet. Some other things to consider too is being able to just purely brute force the password and figure out the password for the wallet. Someone could keep retrying a number of combinations of passwords until they are able to get the password correct to then decrypt the wallet. But again, this was just a quick experiment to really showcase how this wallet experience could work utilizing these tools that we provide. But again, I hope you folks enjoyed this, and if you did, and if you want to build upon it yourself and add more functionality to it, please do so. Share us your results or the things that you're able to create using this. But again, I hope you folks enjoyed the video. If you did, give it a thumbs up. Don't forget to hit that subscribe button. Turn on the notification bell as well so you don't miss out on tutorial videos just like this. We'll drop a link down to the Discord channel if you need any help or support. Our support team in the Discord is happy to help you out. But again, I hope you folks enjoyed this video, and until next time, see ya.